All right, so after all that that other video with all the math talk and the mumbo jumbo there, let's apply this. All right, so let's actually do this algebraically and find those things we were talking about, which is critical values, which will lead to our maxes and our mins. All right, and then also where this function happens to be increasing and decreasing. All right, and just to start off, as we do with all of these, these analysis pieces that we're doing, we're going to start off by taking the derivative of our function. Okay, so we are going to take the derivative of x squared minus 4x plus 5, and it's 2x minus 4. Okay, and a reminder, critical values are locations where it does not exist, your derivative does not exist, slope, there's no slope there, or so at a cusp or something like that, and locations where the derivative is equal to 0. So when you have a relative max or min where it's changing from increasing to decreasing, something like that. In this case, it would be parabola, right? This function, if graphed, would look like a parabola. You'd have that opens up, all right? You'd have a point down there. That critical value, that minimum there, is what we're trying to find, because we know that the tangent line at that point has a slope that's equal to 0. That means we can take our derivative, our slope, and set it equal to 0. All right, in that case, we will solve that. When we do solve that, we get x is equal to 2. So x is equal to 2 is our critical value. Okay, so this happens for this function. This happens at x equals 2. Okay, and that's what we're going to use to figure out the intervals over which we are increasing and decreasing. Okay, so when we have a function like this, the way to do that is we're going to set up a little number line. Okay, and on that number line, what we're going to do is plot our critical value. All right, so x is equal to 2. If we had more than one critical value, we would plot more than one. All right, and then what we're going to look to do now is decide what's happening on either side of that critical value. We know at that critical value that our slope is going to be equal to 0. But we're going to look onto the left of it and onto the right of it and see, are we getting positive or negative slopes there? And if we're getting negative, we know it's decreasing. If we're getting positive, we know it's increasing based on what we talked about before and what you saw on the Desmos activity. Okay, so we know that 2 is going to be off limits for testing points. What we're going to do is test some values here. So we can pick really any number that's less than 2, all right, and we're going to plug that number into our derivative. So I'm going to start by, because we want to find out whether the slope there is increasing or decreasing, therefore we need to know whether it's negative or positive. I'm going to start by plugging, in this case, I'm just going to plug in 0, because that's an easy number to plug in. So when I plug in 0, f prime of 0, 2 times 0 is 0 minus 4, that's a negative number. And really, we care more about the negative than anything. Okay, it's a negative 4. But we care about the sign more than anything else. So the sign is the important thing, because the sign here on this interval tells me that at that part, right, leading up to 2, if I'm going from left to right on my graph, leading up to x equals 2, the graph is decreasing because I'm getting negative slopes. Okay, you only have to plug one value in to test it, but just to show you that it doesn't matter which value you plug in as long as it's less than the 2, I can plug in 1 here as well if I wanted to. If I plug in 1, 2 times 1 is 2 minus 4 is negative 2. It's still a negative value. All right, so anything that I pick to the left of 2, anything that's smaller than 2, that I'd be plugging into that first derivative, okay, I am going to get negative numbers, and therefore I have an interval on my function that is decreasing. Okay, and we'll identify that interval in a second with our interval notation. All right, I also want to test the other side. All right, so I'm going to pick something that's larger than 2. No reason to pick any number that's huge. Just pick a 3 so I can easily plug it in there. And again, I'm really looking for the sign more than anything else. All right, so when I do f prime of 3, 2 times 3 is 6. 6 minus 4 is equal to a positive 2. Okay, and if I plugged in 4, I'd get positive. If I plugged in 5, anything that's greater than 2 is going to give me slopes that are positive. Therefore, I know that that part of my function is an increasing part because I'm getting positive slopes on that side of the critical value. Okay, so I have everything I need now to kind of answer the question that's being said here, which is identify the intervals where f of x is increasing and intervals when it's decreasing, and then state any relative extremity. Okay, so I'll start off by doing the intervals. Okay, so I'm going to start off by saying f of x is let's go decreasing first, all right? And my decreasing interval, in this case, is everything to the left of 2 all the way until I get up to 2, all right? Not including 2, but up to 2. So the way I would write that is negative infinity. No matter what value I pick to the left of 2, it's going to be decreasing until I reach 2, which is a critical value point, which is a transition point, which in this case would be a relative min. And we'll identify that specific location in a second. Where is it increasing? Well, we see that we have positive values there. So f of x is increasing from 2 on, all right, not including 2. So everything from 2 to infinity is an increasing interval, all right, and that's how I indicate where my increasing interval is, okay? And then the last thing it asks for is state any relative extrema. Again, relative extrema happen at critical values, all right, but it has to go from one sign to the other. For it to be a relative max or min, you got to be changing from minus to plus or plus to minus. In this case, we're going from minus to plus. So again, looking over here at our rudimentary diagram here, I'm coming down, I hit my relative min in this case because I'm going from decreasing to increasing, okay? Decreasing to increasing. Think about it in those terms. You know, if you're going from, and that chart that was on the previous video, you can always refer back to that as well in these notes. All right, if I'm going from decreasing to increasing, I'm going to be at a relative min. So in that case, I would identify this as a relative min. Where does that happen? I want the full coordinate, so I know that it's x equals 2, but 2 what? Here's the thing where you have to be careful. It's a coordinate on that original function. So I'm going to plug 2 into the original function, not into this to derivative, okay? You're going to plug it into the original function. So when I plug 2 in there, all right, I go, and you can do this on your calculator, but it's going to be f of 2, 2 squared minus 4 times 2 plus 5, okay? Again, I just do the math on the calculator there, and that turns out to be 2, 1. All right, so at 2, 1, at coordinate 2, 1 is where my graph here, this function, x squared minus 4x plus 5, will be changing from a decreasing function to an increasing function. All right, that's the critical value, it's the relative min. That is the transition location, all right, of my two intervals going from decreasing to increasing, okay? All right, let's do another example. All right, so we're gonna do the same thing here. All right, identify the intervals of increasing and decreasing, and then any relative extrema. All right, so the same thing applies here. All right, I'm still just going to take the derivative. Actually, I take the derivative. So 4x cubed minus 32. All right, and then I know critical values happen at where slope is equal to 0. Okay, slope of the tangent line is equal to 0. So I set that equal to 0. All right, and then I solve. Okay, so in this case, I'm going to end up with 4x cubed equals 32. Divide the 4. I'm looking at x cubed is equal to 32. Okay, and then when I take the cube root of both sides, in this case, x is equal to 2. 2 cubed, or excuse me, going back, sorry, x cubed is equal to 8, and I take the cube root, and that's equal to 2. All right, so 2 is my critical value. 2 is potentially a point where we are changing from increasing to decreasing, all right, or vice versa. All right, and I just have to test to see what's happening on either side of that critical value. Again, if I was to happen to get more than one critical value, I would have to do both, or all three, or however many there happen to be. You have to test on either side of any of those critical values. In this case, it's just 1. 2 is my critical value here. All right, and then I have to see what's happening to the left of 2, what's happening to the right of 2. So again, I'm just going to plug in a value to the derivative. Okay, in this case, I'm just going to go 0 because it's an easy number to plug in. All right, so 0, that's a negative 32. Again, I care more about the sign than anything else. So to the left of 2, I have a decreasing function, okay, as I approach 2. On the other side of 2, I'm going to test 3. Okay, and again, you can test any number to the right of 2. All right, but what happens here is I end up with a number that is, plug it into your calculator, it's going to be a positive number. Okay, so that number there just tells me that no matter what I plug into the right of 2, I'm going to end up with a function that is increasing there. Okay, so you're seeing that at 2, we are transitioning from decreasing to increasing, kind of like we were in the problem we just did prior to this one. All right, same thing is kind of happening here at this 2 location. All right, so now I just have to identify, just write out what are the decreasing, increasing, and the relative extremity. Okay. All right, so where's it increasing, where's it decreasing in that? In this case, I'm going from decreasing to increasing, so I'm going to have a relative min. All right, going down, stopping at a point, which is 2, and then going back up. All right, so my decreasing function, again, would be negative infinity 2. My increasing function would be from 2 all the way to infinity. Okay, or increasing, excuse me, part of my function. And then my relative extremity, my relative min in this case, is going to be 2 something. What that something is, I get by plugging 2 into the original function, because the original function is where I'm finding these critical values at, right? So I have to find that coordinate on the original function that's been graphed. Okay, and then I plug that in to this here, 2 to the 4th minus 32 times 2 plus 4. All right, again, calculator that. All right, when you get your answer, it turns out to be negative 44. Okay, so what's happening here is I would have a point, a coordinate at 2, negative 44, and leading up to that coordinate, I would have function as I move from left to right on this graph that is decreasing, right? It instantaneously stops at that location and then increases and starts to go up from then on.